I'm Dr. Anthony Chang. I think most of you know me by now. There are quite a few people coming back for this really exciting meeting focusing on essentially a new paradigm in medicine, artificial intelligence, and everything that comes with it. So the first takeaway for those of you who are here for the first time is that it's not just about deep learning, it's about everything else as well. I always have a patient or a family here, front and center literally, because this is what all of this is really about. It's not about the really high-tech availability of artificial intelligence. It's not about deep learning. It's mostly about how do we deliver medicine better, faster, more accurately, and increase the value of medicine. So I have here an amazing family that I had the pleasure of taking. We were just reminiscing. It's been almost 10 years now since I got the first, I think, email about Hannah. So do you want to tell us about your medical journey and what are your day-to-day difficulties so we can all appreciate how we can potentially help all of you with your family?
Yeah. So we're the Litzoff family. My name is Jason. This is my lovely wife, Melody. This is our oldest son, Noah, and then our daughter, Hannah. And then we have one missing today. So he had he had school today, so he's missing. And so Jonah, he's in junior high, so he's our middle one. But yeah, so our journey, just really quick, our journey started with actually adopting Hannah. When we adopted her, we knew she had a pretty severe heart condition, and our first real interaction, as Dr. Chang was alluding to, was an email to him saying, hey, we're about to do something a little bit crazy, can you help us? And so we actually emailed him. We sent, when we got Hannah's file, we sent the file to Dr. Chang, and that's kind of how our relationship began. And so Hannah was Dr. Chang's very first patient.
In your family.
In our family, yes. Yes, that's a good clarification. Otherwise,
no one wants to be a doctor's first patient ever, right?
It was a little
but
scary.
The important part of that exchange was, I remember it was an email about, do we need a pulse ox for her? Or do we need oxygen for her on the flight over?
Yes.
And just as an example, how some days we think the healthcare system is amazing with all the technology, but here we are exchanging emails about how to get Hannah safely back to California.
Yeah, not only that, but we got stuck in Hong Kong.
Oh, that's right.
And so the airline actually would not allow us on the plane because of Hannah's oxygen
that's
levels.
Right.
And
that's
so
right.
I think it was some midnight phone calls between you and the airline to actually get us back.
Yeah.
So we're incredibly thankful for that.
And the other unique part of the story was we only had one interaction with you before we emailed you. None of our family had seen you personally, but you took the time to give us a tour of the hospital. And one of the things that stood out was you gave us your card and said, if you ever need anything, please email or reach out to me. So that's how our first interaction went. And you took the time to invest, not even knowing our family and our situation. So grateful for that.
So fast forward a little bit. So Hannah was our first medical patient really within our family. And then soon after that, my wife was actually diagnosed with muscular dystrophy. So she started to have some muscle weakness, and she started to lose a lot of weight, and she ended up being diagnosed with muscular dystrophy. In the process of some other interactions with Dr. Chang and some other some electrical issues with her heart, we ended up, at the advice of Dr. Chang, getting an EKG done on our kids. And so our oldest son, Noah, ended up having a fairly abnormal EKG, which ended up leading him to a diagnosis of restrictive cardiomyopathy, and then a connection, genetic connection with my wife and him. They both have muscular dystrophy.
So there's that recurrent theme that we'll hear about throughout the meeting: timely diagnosis, accuracy of diagnosis, communication with many, many other physicians, precision medicine. Your family sort of embodies all of this meeting in a way. So
yeah. Our life is because there's partly, my son has a severe heart condition, Hannah has a heart condition, Melody has a heart condition, but then they also have the muscular dystrophy to go with it.
Right.
Oftentimes we're seeing multiple doctors, sometimes multiple times a week, and when it seems like it's been working well, is when doctors have been really collaborating well, because it's, you can treat the heart, but really their symptoms are heart and muscles and every other symptom that goes along with it. So, yeah.
So it's been an amazing journey for this entire family. I see adult patients too, so I think there's a new emerging title of family cardiologist for those of us who see adult patients. So, for our keynote speakers, how do we make sure all of this is going to come together is the complexity of biomedicine. And by the way, tell us what Hannah's planning on doing for her career without any encouragement from me, by the way.
Do you want to tell
Ever since you were 8 years old, what did you say you want to be?
A cardiologist.
Yes.
So she's actually here for several reasons. One is to take notes, and she wants to learn something. And she's obviously, just like all the patients, very special to me. But when she came up and said she wanted to be a cardiologist and sent me a picture from, I think, was it a Halloween party, dressed up as a doctor, it was really very inspiring for me. And I actually gave a TEDx talk on this, how she's inspiring for multiple reasons. But I think this coming generation of physicians is going to be very, very savvy with technology, much more savvy than previous generations. And so someday you'll be hosting this. You'll be in my seat hosting this meeting. How about that? Would you be willing to do that? She asked me, is Oprah next? So, no, I see amazing story with your entire family. It's inspiring for me to be part of the care for your family. Can we, anything else? Hannah, do you have a last word for us from your perspective? No? Okay. Jonah? No, I'm sorry, Noah? Do you have any advice for doctors? Our audience typically is about half clinicians and half, technology-related people. Okay.
I would just say, sitting in a room like this, our family interacts with so many doctors. It's, years ago, we never thought this was going to kind of be our life. In a lot of ways, as we go through our week, oftentimes, my wife's looking at her calendar and she's saying, how many doctor's appointments do we have this week? How do we get to those doctor's appointments? I'm trying to also work at the same time, and there's seasons where it just seems like, man, that was 3 doctor's appointments this week. And so,
right.
So we're incredibly appreciative. We never realized how appreciative we would of doctors and the medical community. And technology. In reality, my wife is alive right now because she has a pacemaker that's always good. She's alive because of that technology and those developments. And so incredibly grateful for the ways that so many doctors, medical people have invested in our family in really important ways. And so, just a big thank you really is kind of my
but still a lot of work needs to be done in terms of logistics. Communication.
Sure.
Sometimes our communication comes down simple text, despite all the technology and apps available.
That's
the human-human connection,
Absolutely.
right?
Yeah.
So, can we give them a round of applause, please? So I'm going to basically just give an introduction. If we have my slides up about the meeting. I'm just curious, how many people here are coming for the first time? Okay, so about half. Okay, so I'm just going to give a brief meeting overview so you kind of understand what's happening this next few days. So this is to remind me to thank all the amazing sponsors. Some of them are here for the 3rd time supporting this meeting, which, as you know, of this magnitude and this size and this complexity, really grateful for the many, many sponsors. And some of the sponsors will be helping me with a keynote session. So thank you again for your amazing support. So today, we start with a keynote session. It's a little bit different than your traditional. So this meeting is different in many ways. We like a fast-paced meeting. We shoot for a 50-50 split between presentations and conversations on stage. And that's pretty much what you've asked for. So we're trying to deliver that. So the keynote sessions are mini keynote talks with a conversation. There's some plenary sessions focusing on some of the important and relevant topics. And then we really took in your suggestion, which is for some of you who are returning, okay, we get some of the theory now, let's have some real world application sessions. So we've blended in with the plenary sessions that will talk about application in real life, as well as subspecialty focus as we get more and more sophisticated, as well as how do we do this or how can we do this. So the how-to sessions are particularly, I think, good also. And then we have a triple header for tonight. Thanks to Freddie and his team, we have the open forum. So that's when you can really get going on your Twitter and tell us what questions and thoughts you might have. And then as part of the open session forums, we're going to have the 2 of the 6 abstracts presented, and then we're going to have our faculty from the day back on stage and to answer your questions. The second thing that's going to happen tonight, which is kind of becoming one of the trademark events for AI Med, is a Shark Tank-like meeting or pitch event. We're going to have 6 or 7 companies pitch and have real awards. And then we end tonight, it's a long day, so we end tonight with a special AI Med social event. So it's going to be a barbecue. So this way you can really network. And one of the important aspects of this meeting is to network. And I feel like the ultimate matchmaker, always saying, oh, you got to meet that person from Canada or this person from Senegal. Usually about 25 countries are represented. So not only can you meet other people in the same field or different fields that you need to connect with, but also from an international range of countries. Tomorrow, so hopefully you'll have a nice rest because it's a very long day today. Tomorrow in the morning at 7 o'clock, we have a special breakfast, particularly for physicians with a strong data science or AI background or interest. So we're trying to put together an agenda to move forward. We met last year and we really made some inroads in terms of gathering this group of clinicians to really push the agenda, particularly with national organizations as well as international ones. And then a similar format for the rest of tomorrow. We're going to have plenary sessions blended in with real-world application type sessions, how-to sessions. And then tomorrow evening, we end with the open forum, the second one, with a couple more abstracts. And then to follow that, the abstract presentation of all the abstracts that were accepted this year. So please make a point of going to that session and support particularly the younger generation of clinicians and researchers that will be pushing the field in the near future as well into the future. And I'll save Saturday's agenda for tomorrow. So this is a sort of a trademark also for the meeting. We have incredible sunsets here. So this is a sunset from my balcony a couple of nights ago. And we have a sunset break built into the program. So sunset's at 4:44 today. So we break at 4:30. So whoever's moderating that session, please remember we have a sunset break. So we warm up the audience. Typically, in previous years, has been James Bond trivia. I think some of you are fatigued with that. So we're going to have an AI trivia, okay? So someone asked me, can we search for the answer? And I said, this meeting's about human and machine synergy. So any way you get to the answer is fine with me, right? So you're allowed to search, you're allowed to Google. And whoever shouts out the correct answer first gets, yes?
Just one thing, we've got some really nice prizes as well. We've got treatments, we've got a meal at the restaurant.
To add to this? Okay, so now the stakes are even higher. So I got you an authentic Curacao dye Laguna t-shirt, okay? This is going to be worth a lot of money someday, okay? So, and then Freddie just added a spa treatment, is that right? A spa treatment? So, okay, so there's a lot riding on this, okay? You ready? All right, so I'm going to show the question. We're going to go to the first human that answers this question with a loud answer that I can hear. Ready? Okay. The one word that separates human and machine. This was pooping. I'll take pooping. Who said pooping? This is according to the. Let's give him a hand or. Okay.
We do actually have as well. We've got spa treatments. We've got a meal for two at the Raya restaurant.
Yeah.
But we can, as the day goes on, we can give out
We'll
other prizes.
raise the stakes as
We
the
will,
day
we will.
goes on. Okay. I'll have to come up with some more trivia questions. But according to I'm in a generous mood this morning because technically the word was poop, but I'll give it to you in the verb form. According to an MIT study recently, it's sort of a mini Turing test trying to separate humans from machines. And apparently, I think people would naturally guess words like love and please, but it turned out that poop was the one word that machines never said. So in the near future, when you get into a bizarre scenario trying to separate a robot from a human, that might come in handy. So, all right, so quickly, I'm just going to talk, I'm holding myself to the same guideline as we do with the keynote speakers, 10 minutes and 5 slides, so move things along. So I thought a nice topic would be sort of the year in review. We had an amazing year looking back. And those of you who are not familiar with the history of AI in medicine, this is history of AI in medicine on one slide. So in the 70s and 80s, actually one of my Stanford mentors, Ed Shortlift, was experimenting with expert systems where you ask a computer a question, you get an answer back. Because of lack of data and slow computation, that wasn't really widely adopted. So we're here now in the middle of the machine and deep learning era. And as we go forward, everyone is expecting and hoping for what we call general artificial intelligence. Or you remember from Star Trek where Captain Kirk asks a computer a question and gets an answer back? That's what we're hoping for in the near future. And I think it's going to come not in an obvious way, but we're just going to slowly get there. And one AI guru said it best, you don't call it AI when something starts working, and which is, I think, really a very insightful comment. So when this is my second daughter, when she was 1, so I feel like this past year, we saw a lot of growth and development. This was last Christmas, so in that 1 year span since last year we met, I think lots of things have happened. So I'm just going to frame it in 5 slides. There's been a lot more increase in investments and applications. So when you look at investments, this is an amazing statistic. If you think about, when in the middle of this period in which the compounded annual growth rate for AI is going up 40% a year, and doesn't look like it's slowing down. We did a meeting in China, is just near mania over there in terms of investments in artificial intelligence. So that's going to continue for the next few years. And that leads to very important sort of landmark events. And as you may have heard this year, IDX, which is ophthalmology software, cleared from the FDA for autonomous decision. So this is a tool for primary care doctors even to use. That's cleared, but not, I think, fully approved yet, but cleared by the FDA. The second clearance was given to Zebra Medical, and then the third one is for the Apple Watch, the Series 4. We're actually going to have an interesting patient come up tomorrow and tell us about her personal experience as a patient with an EKG device. And we'll hear the pluses and the minuses. So we're starting to get into the ethics and the practicality, the business aspects of these AI tools that are now available. The second thing I noticed is in this past year, a tremendous increase in the presence of in academic journals. But based on the titles, these are usually editorials with sort of a question mark for artificial intelligence in medicine. But at least now we have presence. Remember last year when I talked about this, there was hardly an article published in a prestigious journal. So now we're seeing it in abundance in JAMA, Nature, as well as Lancet and British Medical Journal. So the journals are starting to appreciate that this is a hot topic, and there are editorials and now even review articles written on the topic. So I think it's taking foothold in the academic journals. The third takeaway is if you look at the year in print, the popular books, these are 2 books I highly recommend. One is The Prediction Machines. We actually had an opportunity to meet one of the authors while we were in Toronto and talking about the future of artificial intelligence. And there's a lot of discussion about health and medicine in these two books, actually. That'd be very helpful, particularly for clinicians just starting in this area. And then these two magazines I recommend. One is the HBR, Harvard Business Review, on machine learning and artificial intelligence. It actually has articles relevant to healthcare and medicine. And the Wired magazine that just came out this month has an amazing assortment of articles focusing on what's really relevant in artificial intelligence. And I think the title of that magazine really is very appropriate for this era, which is we need it to be more intelligent and perhaps less artificial. As we head around the world this year, as some of you know, we've been to London and Beijing, Shanghai and Hangzhou, and as well as other cities around the world. One thing I noticed is that when you look at the AI landscape in a particular country, and then you add on top of that the healthcare landscape, it really creates amazing dynamics. I'll give you one short example. When they asked me in China, what would I find useful for facial recognition software, which is one of their strengths, I said, well, wouldn't it be nice, I'm a pediatric subspecialist, that every child that comes in gets facial recognition software focusing on potentially a missed diagnosis of a genetic syndrome. Because as you know, 30–40% of genetic syndromes have a delayed diagnosis. And I said, well, what do you use it for? And without hesitation, they said, well, we use it to make sure that the pharmaceutical reps that we don't like don't come into the hospital. So, so just interesting dynamics when you start talking about AI and healthcare between different countries. So this is sort of we'll have actually a whole session on AI around the world that's coming up after the keynote session, but this is sort of a quick snapshot of what's happening. Obviously, a lot's happening in the US, but other countries are catching up and definitely making a big difference, particularly China. We were just in the UK. It's an amazing amount of activity in the EU as well as the UK. And then there's some spots around the world that are definitely considered epicenters, and we'll talk about that in the next session. But again, when you blend in AI with healthcare in each particular country and how they have to deal with AI is really fascinating to me. And speaking about the world and AI, it always comes down to the human-to-human bonding and interaction that we talked about. So I have many, many pictures from this year. I won't have time to show it all, but this is one of the ones I remember best. It's myself with the Toronto group that we've gathered, and I showed up at 7 o'clock to give the talk, and there were close to 100 people already there. The level of enthusiasm was just amazing to me. So we have a tech executive. Karen is a surgeon that you'll be meeting in the next session. We have Ben, who's a data scientist, clinician, and we also have someone who's a primary care doctor with an interest in deep learning. So amazing assortment of people all over the world. And I also have a chance to hang out with AI Med faculty. And while I was busy with other things, they had time to enjoy it. Yes, that does spell AI Med. A little bit on the goofy side, but the human-human bonding with the faculty, we've really enjoyed also. And for myself, I'm the ultimate nerd. So for me, while I was in London, I just had to go to Bletchley Park finally. And those of you who are familiar with Alan Turing's work, I'm sure I broke the local laws by sneaking across the roped-off section and had to take a selfie next to his typewriter that's been sitting there ever since he passed away. So it was a surreal moment for me. I literally stayed there for 20 minutes until they chased me out of there. So, so something about connecting with Alan Turing really meant a great deal to me this year. So one of the reasons we brought up the Lietzau family is to remind all of us and be inspired and grounded as we talk about all the interesting technology that's available. With this quote from Marie Colvin, who was, as you recall, an American journalist that was killed, unfortunately, in Syria. I think it was 2012, during a bombing, and I think particularly, potentially assassinated, actually. And her second favorite quote was, and why she confronts all this incredible risk is, these are not just numbers that you read about in the newspaper about people dying, but she wanted to tell the stories of each person. So that really resonated with me this year. And I want to thank, in addition to Freddie White and his team, also my extremely generous, supportive donor, Michelle Lund, who is the granddaughter of Walt Disney, that allowed me the vision of opening an AI institute within the hospital, and also my very patient mentors and friends at Stanford for giving me the opportunity to learn about data science and artificial intelligence. So we had an amazing workshop session yesterday, and people want to know where can I go and get more information, and this is a website that Freddie and I worked on all year. This is where a lot of the resources are available. The ebook in its 3.0 version is uploaded for you to enjoy. That's heading to a publication as a hardcover book by summer next year. So it's focusing on artificial intelligence in medicine, particularly applications. And then Charlie Maloney and I work on the academic magazine. You have copies of that available here. And we are pushing out issues every month or two and focusing on the theme. All the talks from previous years are uploaded as well, and we'll upload the talks from this year, I think including the workshops this year, so that you have plenty of resources, hopefully, for the next coming year. And welcome back to Laguna, or welcome to Laguna. Thank you very much. So next, I'd like to introduce our two mini keynote talks. One is from Fran, who's an amazing person from Hewlett-Packard, and as you know, they have really invested a lot into augmented and virtual reality, as well as just tech in general and healthcare. And then Kevin Lyman from Analytics, so a company that's focusing on medical imaging. So who's going to go first?
I'm headed up, I think. Thank you. Good morning. It's a pleasure to be here with all of you. My name is Fran Ayala-Somayajula. I'm the head of population health worldwide at HP. And I want to kind of switch gears just slightly. I appreciate Anthony referencing early on in his presentation that when AI is working, we don't think about the AI. And when we think about the sources from which the data derives from, it often comes from endpoint devices. And our experiences with the AI comes through outputs from those endpoint devices. And so that's going to be a little bit of the focus of my presentation for today. And I'll start off by sort of just kind of reiterating it here. You know, we think about the multitude of data that exists within the world, and 30% of that data, in fact, is associated with healthcare. I actually personally believe that those numbers are actually higher, that percentage is actually underestimated. And one of the reasons for that is because of the multitude of sources from which information derives. And when in healthcare we start to talk about things like social determinants of health, or we begin to talk about personal generated health data, then those numbers begin to escalate. Let's switch gears now and consider it from the standpoint of where the industry is today very broadly. We, through the AI Met Journal and through our conversations as an AI Met community, we often talk about many of these stories of use of chatbot technology, even isolated cases of use of robotic technology. But the progress has really been amazing, and it's going to be scaling. And there's some reasons for this. Telehealth is a great example. Actually, just last week, I was in DC with the Veteran Affairs, and they were talking about the progress that they have made with the already existing over 300,000 veterans who are partaking in their program. Ellie, similar to Flow, which are both chatbot technologies, are currently being utilized and are scaling. So we're not only seeing these investments that are being made in institutions and oftentimes very controlled environments, but we're also beginning to see the very large institutionalization through government entities that are making this happen. And there's some reasons for this, right? If you think about, I love this term, the non-worried sick, Dr. Setu Vora in Connecticut, who's the CMO there, Chief Medical Officer for the tribal communities, coined this phrase, and it sort sort of refers to many of the non-communicable diseases for which we often don't see the symptoms, right? They're asymptomatic. So the patient who is diabetic, but is not really exhibiting those symptoms, or the individual with heart disease that's challenged. And then we've got individuals in rural settings. It was amazing last week to hear both T-Mobile as well as Verizon stand up on stage and say that they're going to be providing zero charge for veterans' use of their telco services for telehealth services, for those telehealth programs. So it's pretty significant, things that we're doing for outreach. We're also seeing that these telepods that are being created and the government investing directly in that, so that by next year in 2019, partnerships with groups like Walgreens are going to start to take place. And then within densely populated areas, we're also beginning to see amazing programs that are being instrumented. And some of those center around just making sure that the infrastructures exist, such as the changes, the readiness, if you will, for 5G. It's coming, right? 3 is out. So there's actually going to be a point now where no more devices are going to be built with 3G technology. You're going to have to be in 4. And we're already having conversations in multiple countries, even within the East African community, which is a conglomerate of countries that have come together under one passport, who are discussing how they want to build an infrastructure, and they're talking about building that infrastructure on 5G. And with that then, enabling things like the use of robotics and telepresence to address some of the issues that we see in some countries like Sierra Leone, where you only have one surgeon for every 600,000 patients. Pretty significant opportunities. So these elements are shaping the national agendas, and investments are taking place at the same time. The other thing that's very apparent is that we have an aging population, right? Not only are we a growing population of approximately 1.6 every year, but we are also a very aging population. Every year, over 10,000 people turn the age of 65. And there's a term that some of you have probably heard, called the silver tsunami, a term that I really don't like. And the reason I don't particularly care for it is because I really believe that there is a silver lining. What we are finding is that older adults are embracing technology. So all of the things that we are talking about that are enabling the care continuum by extending the delivery of care, the communication between providers and patients outside of the 4 walls of the clinical setting, are things that older adults are actually embracing. I spent a lot of time with the older adult community, late stage older adults, average age of 76 years of age and older, and we introduce technologies to them, and they're very receptive to the technology. And in just a second, I'll show you some of the comments that we gather from them. But one of the things that we find overall is that there's an opportunity to create for simplicity. And smart devices, in my opinion, are the things that are truly in fact, fueling AI. Right? You've got to have the data. And the data doesn't just exist in EHRs. I encourage you to begin to think about your opportunity, if you're not already engaging in the use of programs like remote patient monitoring, which allows for you to get not just retrospective insight, but also progressive insight on what's going on with a particular patient. There's real opportunity within that environment. And of course, that's true across the board. For our investments and the investments of many others, we are seeing the focus continue to be pushed in the direction of 3D transformation. For us at HP, that can even extends into the use of sensor technology built within prosthetics that are 3D printed, or the use of hypermobility. How do we make it easy for individuals to have access to information and in new forms? When you're at data scientists, as an example, are very busy looking at multiple forms of data and at a variety of formats, how can we leverage technology, imaging display technology as an example, to really alter the perspective and allow you new ways to interact with your data and in real time? Smart machine capability, that's inclusive of robotic technology, is another area that is a growing area. There's a lot of investment which is going into that environment and for which we stay committed. Immersive experiences, and this is really a rather interesting topic because this is where you begin to see this, what we call blended reality, where it's not just virtual reality, but it's or augmented reality, but it's also the way that general objects within your space and your environment can be used as a point of intelligence, which is really rather unique. And of course, then the Internet of Things is another big one. I mentioned earlier that I was going to comment a little bit more about the older adult community, and I use them to highlight robotic technology in particular, because sometimes the opinion is that older adults are not ready for this technology. One of my pastimes is that I actually do yoga, and those of you, kudos to those who made it this morning at 6 a.m. That was really awesome. Typically, I must say, these days, I have been doing it with older adults in my home, chair yoga, virtually. These individuals are all across the United States. My oldest student is 90 years of age. She turned 90 in August. So it's pretty awesome. And what we've been doing as well is going into the community and introducing technology, sometimes, most of the time, in fact, unbranded, and we present the technology and allow for them to tell us what they like. When it comes to something like a tablet or a mobile phone or all-in-one, so what we call form factors, it's interesting to find that what their preferences are. Their preferences are obviously skewed towards high visual and auditory acuity, right? You can't really appreciate something if you can't see it or you can't hear it. Or even dexterity is really important. And so you can imagine that when we introduced robotic technology, they got super excited. Although there was one gentleman who said, "That's great for my mom, but not for me." And I looked at him and was like, okay, it's comical. But, and why did he say that? He said, because of privacy. I want to maintain my privacy. So these are just some examples you see listed there of some of the ways in which they would use it, increasing their interaction with the clinical community, helping them to make their lives easier on a day-to-day basis. I'm super excited about this technology. I know you all are all here because you are as well. You're going to hear a lot of different themes over the course of the next 3 days, and I'm excited to be able to go on this journey with you. So thank you.
First off, thank you all for having me. My name is Kevin Lyman. I'm the CEO at Enlytic. We're a startup in San Francisco developing clinical applications of artificial intelligence for radiology. And when I first joined Enlytic about 3.5 years ago, my original role was forward deployed engineer. I come from a background in deep engineering and research, and it was my job to travel on site to providers and shadow their clinicians, understand their needs, and build a deep empathy for the problems that they actually need solved, but to also on the fly rapidly prototype solutions to those problems, take those learnings back home and use them to optimize our own research path. And in the process of doing that, I learned a lot about the specific challenges that exist in translating these solutions from research into practice. There's good reasons why every day we see probably a dozen new research articles and other papers indicating that AI has now beaten a radiologist at a new task. And yet, if you ask all of your doctor friends, you're not really hearing about people using these things ubiquitously in practice. And while the field is getting there, there are still some big roadblocks that stand in the way. And I'd like to spend the next 10 minutes or so going over some of those topics, really just briefly enough to get them on everybody's mind. Because over the next few days, we've got some of the best and brightest minds in technology and medicine who are deeply interested in solving these problems. And so getting them on everybody's radar, we can all work together on how to get past them. And along the way, I'll try to give you a sense of what we do at Enlytic to try to get past some of these problems ourselves. So to start, radiology data is highly nuanced, and unintended bias is hard to avoid without proper education. If you're building a diagnostic aid, it's critical to understand the difference between diagnosing something and detecting visual patterns indicative of a differential diagnosis. Looking at a chest X-ray image, I can say with a certain degree of confidence that a patient has a calcified lung nodule, a pleural effusion, maybe consolidation or cavitation. But making the leap to diagnosing tuberculosis with nothing but a JPEG is a different story. And again, this is an example of a type of problem that's hard to appreciate without a proper medical background. But when you're building tools based on these assumptions, it's critical that you take the time to learn these proper issues and build around them. For this reason, at Inlytic, we require that all of our engineers and data scientists sit side by side with radiologists every single day in order to ask them the appropriate questions, in order to watch their workflow, and in order to learn more about the proper practice of radiology. At the same time, our chief medical officer has put together a medical lesson plan for us. And every week, we rotate through different advisors and clinicians on our staff who train our engineers and data scientists about different topics along the way. Now, on that note, we need support from many experts, not just radiologists. Building good product requires a holistic understanding of the ecosystem wherein you're developing. A good example of this is the field of image acquisition. If you're building a model that interprets an image, then you need to care about how that image was acquired. Different studies, say for a CT scan, might have different windowing levels or preset reconstruction kernels that dictate the intent of that study and also put constraints on how you can even read that study. Now, if you're building a model that interprets a DICOM image post-processing and not raw sensor data, you're beholden to the same constraints as a radiologist. And so it's important that you learn to appreciate them. For that reason, we don't just employ world-class radiologists, but also technologists and technicians who have expertise in image acquisition. Extending that further, practice management is another critical aspect of this. It's important to learn about all of the inputs and outputs that your user, the radiologist, will be dealing with as well. Number 3, more time is spent building tools that enable us to develop clinical AI than actually building clinical AI. In the past 4 years, we've had to develop state-of-the-art tools for gathering massive amounts of labeled data, for validating the output of models, for training across large distributed clusters, for integrating into a real clinical environment. All of these tools have to exist before you can use them to sustainably build clinical AI. And each of those are incredibly complicated products in and of themselves that have their own lengthy product development cycles. And while it's very educational to go through the swings of building these things out, it's a little bit of a distraction from actually building the core product that we can put into the hands of clinicians themselves. As an industry, over the next few years, I'm deeply hopeful that we'll see people move toward open source tools and sharing among a community in order to really help level the playing field. In reality, it's really hard to mine for gold if you have to start by building mining picks first. Number 4, privacy and security are subjective measures with moving targets, especially on a global scale. Hipaa guidelines recognize 2 paths to patient safety and de-identification. One is called Safe Harbor, and that actually has a detailed list of guidelines that one can follow. But unfortunately, nobody seems to care about that, and what they usually follow is rule number 2, the rule of expert opinion. And that means that you need to remove enough identifiers such that an expert who is well-to-do in the field could not reasonably identify that patient. That's a very vague set of definitions. And unfortunately, in practice, every radiology group, every hospital, every health system or company has their own internal expert, and their opinion on the topic seems to change every single day. And so for that reason, the tools we've built for de-identification have to be enormously customizable. And not just for anonymizing metadata, like DICOM headers, but for identifying names and addresses in freehand text reports, even if they might be burned into an image. And again, while those are challenging and fun technical problems to solve, the bigger issue is that everybody needs to care about privacy and security. So we need proper standards that everybody can follow, rather than opinions that can change setting to setting as we go along. Number 5, I know this will come as a surprise to everybody, but most hospitals do not design their software infrastructure with ease of AI integration in mind. Again, having been the forward deployed engineer, a lot of my role was wrestling with antiquated hospital systems, trying to pull back Band-Aid after Band-Aid solution, where you can see over many decades the evolution of just introducing new systems and messing with them until they work. This creates a very challenging environment to actually deploy new software into. I think the best thing that we can do is continually put pressure on our hospital systems and other healthcare providers to optimize and modernize their infrastructure, not just for ease of AI integration, but for many reasons. In practice, there's no reason why we should still be using the same PACS or EMR for 15 straight years. Technology has come a long way in that time. We should also be putting pressure on our vendors and manufacturers in order to adopt open standards and APIs that can make interconnecting these systems far easier in the future. Number 6, models don't get regulatory approvals. Claims around very specific intended uses of a model get regulatory approvals. For example, we've trained our chest X-ray models to identify, ideally, every possible anomaly that can occur in that type of study. That is an incredibly ambitious claim, and it is one that is incredibly unlikely to get approved by the FDA, at least not unless we were to go through a validation study with a statistically significant number of examples of each anomaly that we qualify as everything. And of course, that can take quite a bit of time. Now, a lot of the regulatory challenges become even more difficult when you recognize them properly as unknown unknowns. Now, how does one design a trial to validate a tool that differentiates normal from abnormal? How about a tool that helps a doctor identify malignancy and act on it 2 years earlier in time than they otherwise might have? Many companies, Inlytic included, are currently trying to work with not just the FDA, but regulatory bodies around the world to force them to help answer these questions so that we can act on them. Number 7, validation is expensive, but it's important to repeat for each target population. Turns out it's not cheap to hire 17 radiologists to each read 300 to 500 CTs twice, once with and once without help from your tool. And more importantly, while that rigorous validation might mean a lot to the US FDA if it's done on an American population, probably doesn't mean much to the Japanese PMDA unless it's run on a Japanese population. Each population has different incidences of different anatomic variations and abnormalities, different imaging and study protocols, different definition of what requires follow-up. And for that reason, it's critical that you do proper validation on every intended population and in every intended setting where you plan to deploy your tool. And that can get expensive very quickly. Number 8, workflow integration needs to be as convenient and non-threatening as possible. Ultimately, good product design has to start with good user experience. There's no sense in spending all of this time and effort building and validating a tool that gets 0.98 AUC at a task that nobody cares about. Ultimately, we need to start by sitting with the radiologist or the clinician, and we need to understand what their proper pain points are and introduce a tool into that ecosystem in a way that's not going to distract them and create more problems. Historically, this is the difficulty we saw with the predecessor technology to AI, CAD. That it requires that you swivel to a different screen every time you want to load up this tool for a different type of study. And even when you do that, it overloads you with false positives and other irrelevant information. We need to resolve these issues in order to drive adoption of these tools. Number 9, adoption requires buy-in from every stakeholder, and unfortunately, they all speak different languages. Ultimately, we need buy-in from the patient, the radiologist, and the financier who's ultimately going to sign the check to deploy these tools. And unfortunately, most of the time, those value propositions are at direct odds with one another. Theoretically, it should be straightforward to prove improvements in true positive rates alongside simultaneous reductions in false positive rates and read times, but translating that into concrete economic value really requires you to deploy your tool and monitor for a year to see what the actual economic impact of it was. It's pretty tough to actually make the leap to the economic benefit without actually doing an outcomes-based study. And finally, number 10, not all problems in radiology are created equal. Some are more impactful and some are more attainable than others. To a non-radiologist, lung cancer product might mean something, but to a radiologist, they want to know what that means. Are we talking about nodule detection, diagnosis, characterization, longitudinal tracking, measurement? If it's measurement, is it linear? Is it volumetric? Are we talking about automated reporting, triage, QA? Ultimately, some of these problems are easy to solve, but unfortunately, some of the easy ones to solve aren't all that useful. What we really need to be doing is spending a lot of time with clinicians. Those of you that are here today who work in medicine need to be informing engineers and data scientists what are the critical issues that you need solved so that we can focus our attention on building those things rather than simply building what's shiny and cool or easy to write a research paper about. So that's my 10 points. If you'd like to see the inverse of this talk, where instead we talk about why AI is actually quite easy and understandable, we're doing a series of continuing medical education courses next year on AI explainability and interaction for clinicians in the US, Australia, and Japan. So if you have any questions about that or ever want to chat about anything, feel free to shoot me an email, kevin@inlytic.com. Thank you.
Thank you, Kevin. I think you and Fran are particularly good at connecting with medical professionals and spending time with them, and I know that that's sometimes not exactly in your job description. So so our audience is almost evenly split between clinicians and non-clinicians. So what would be your takeaway for both groups? We'll start with Fran. I know I put you on the spot with that one.
Take away from.
For the clinicians that you think are important to remember from your perspective, and then also your non-clinician colleagues here.
Yeah, from the clinician side, I think it goes back to that being able to share your problems or articulate them in a manner that's prioritized, because oftentimes we describe we want the moon, and that's challenging, and getting down to what's practical, what you really intend on putting into use. And from a design perspective, it's about knowing your end user. Oftentimes we create things that are useful but are not well received or accepted. And just working with one group or population, if you're intending for an application or for a device to be used by a diverse population, and you need to go into and do work in diverse populations to make sure that what you're creating actually works in those environments. And that could be just down to localization and language.
Yeah, I'm seeing that more and more as a recurrent theme for studies and AI projects is diversity. Really has to be blended in, and how do you, like you said, Kevin, how do you get something that's approved for Japan that's already approved here or cleared here?
And I guess my main takeaway or point of advice would be for both sides of the people here, for both technologists and for doctors, talk to each other. This is not a one-person problem. This is a massive team of people problem where everybody needs to be talking to everybody else. And not just data scientists and clinicians, but engineers of all types, designers of all types, business people who can understand the financial constraints. This is inherently an incredibly multidisciplinary problem. And it really requires that everybody be at the table together sharing those insights. And I would extend that by saying that the conversation needs to get particularly nuanced before you're really sharing those insights between each other. I think it's critical for any engineer to actually put what they're building into the hands of a clinician right away. And not just do it in a closed environment, but in a real environment where you're ultimately exposed right away to the actual challenges that exist. And I guess another point I'd like to make is for primarily clinicians is ask the right questions as you're looking to adopt these technologies. Be skeptical of the technology that you're looking at, because a regulatory approval does not mean that it's going to work for you on your data set, for your population, given your technical constraints. A regulatory approval means that it happened to work for the 300 cases the FDA required that it run on. But ultimately, trust it once you've seen it run in your environment on your data. And for engineers, the inverse takeaway from that is you're not learning until people are using it.
Yeah. No, I think the point about simply talking to each other, I think AI projects are not meant for group emails or conference calls even. You actually have to go and meet people. I think with Analytic in particular, I actually visited you guys a few times where you are, and then you've come to my hospital, and actually that really builds a depth of human-to-human relationship that you need, ironically, to drive a machine project. So, and then I want to end with our amazing family here. So you have the same question. What would you like to tell the clinicians here and the tech world in terms of advancing your agenda to take care of your family?
Yeah, so I think the one thought I had, you had brought up Star Trek as a part of your time of sharing, but as a patient, one of the things I think I'm thinking about is there's been Hollywood has, we're actually, as you guys are talking about AI, some of this stuff is things that have been in movies that were 20 years ago, and so I watched movies that had some of this technology, and it was very futuristic.
Yeah.
And I think, as a patient, a lot of my perception, probably our perception, has been formed from a lot of those movies. And so there's maybe a little apprehension to kind of go, well, in that movie, the AI took over the world.
Yeah.
So, so I can see the benefits, but I think from a patient perception, I think for patients to begin to understand the benefits of AI in the diagnosis process, but it's not like what Hollywood's claimed it to be,
Yeah,
and
yeah.
there's some perceptions out there. Yeah.
Well, it's misconceptions from all sectors in society about AI, and I'm glad that we finally are not seeing the sort of the commonplace robot as a magazine cover any longer. So, although it still exists, but you're right, it still comes down to what your experience is, right?
Yeah.
So,
Right.
would you be comfortable? Speaking of robots, would you be comfortable with a avatar or robotic presence from the medical world advising you or guiding you instead of the visit to the clinic? Or what does your family feel about having some telepresence or a robot?
Yeah, I mean, my first thought on it is it's different. It's new.
Yeah.
It's not comfortable. So as uncomfortable as going to the doctor is, it's at least familiar, and you know what to expect. I think, with technology and AI, my first thought, never having really experienced the use of it, is it's really different. It could be uncomfortable, and so it's hard to know.
Would you trust, let's take the robot out of the picture. Would you trust a intelligent algorithm to guide you? Let's say one of your children has a fever. Just make it more commonplace than cardiac-oriented issues with a fever. Would you feel comfortable getting advice from an algorithm online?
Yeah, if it works.
Yeah, if it works. Yeah. There's a lot of debate about that, and there are some companies out there giving medical advice, and because of availability issues from their clinicians, but there's upside and downside, obviously.
Yeah, I was just going to add to that. Even as patients, we want to learn and understand. This is our bodies; these things are happening to us. So even sitting up here, I'm amazed at all the technology, and I want to learn. I want to know what the benefits are going to be for me.
Yeah.
So I'm excited about the things that have come up, just like the Apple Watch, EKGs, those kind of things, allow the patient to get the information themselves. But I think from a hospital perspective or doctor perspective, I think we need to take the time to actually educate the patient on a lot of the information, because we want to know.
Yeah.
It takes a lot for us to even trust humans and doctors. We want to be educated by them too, but a lot of this artificial intelligent innovation stuff, we want to be educated on that first before we can fully trust it.
Well, you've been so nice about educating me on what you have, because it's such a rare disorder, and I think now we're going to potentially introduce a third partner, which is our tech partner in a way, in all different forms. So it's like a physician-patient relationship now is changing to adding a partner, so it takes both of us to understand the limitations and the advantages. So.
Right.
All right, with that, we're going to take a quick transition break as we head right into the first session. So thank you very much.
Thank you.
Thank you.